Alright, so guys, today we're going to learn how to add and subtract rationals. Here was your warm-up problem. Caleb, walk me through this first one. How would I add 3/4 plus 7/4?
You add 3 and 7 and keep 4 because it's the same on both sides.
Awesome.
That simplifies to 2 1/2.
So 5/2, which is 2.5 or 2 1/2. Awesome, thanks Caleb. So guys, if you have a common denominator, then you just add the numerators, right? Now Isaac, on yours, we have 3/4 plus 2/3. We don't have a common denominator, so what are we going to do? Yeah, so what would I need to times a 4 by? What would I need to times a 3 by? But if we multiply the denominator, yeah, multiply the numerator, right? So what would that give me here? Great. Now do we have that common denominator? So we just add the numerators and we get 17/12. Can we simplify that? That one we have.
Well,
oh, okay. We could write it as like a decimal or something, right? But as like a reducing, we'll just leave it like that. Okay, guys, this is what we're going to be doing today. You're going to add rational expressions. Well, if it has a common denominator, then what do? Add the numerators, right? What if you don't have a common denominator? Then you make it have a common denominator, and then you add the numerators. Okay? So, let's actually do 2 easy examples. So, in your notes, let's look at number 1. Do we have a common denominator? They're both 9x. So, what I'm going to do is I'm going to add those together. So, I'm going to take the numerators, x plus 2y, and add it with the other numerator, 2x plus 5y. But that's all in one new fraction with 9x in the denominator. Now in the numerator, we're just going to combine like terms. So Melissa, what could I combine in the numerator? What would be considered like terms?
The 2x and the x and the 2y and 5y.
Awesome. So let's do that. X plus 2x, that's 3x. 2y plus 5y, that's 7y. And then that's over 9x. Are you guys okay with that? We had a common denominator, add the numerators. Now, we're always going to check if we can simplify. And I'm going to show you how a lot of people do that and they do it wrong. They'll come here and say, hey, 3/9, that's a third, and x's, and they'll cross it out. And that's not okay because, guys, this has a force fill around it. It's in parentheses. The only way you could simplify is if you factor it out from both terms. And since they don't have a greatest common factor, I can't factor out anything else. So I just leave it like that. Sounds good? Let's go to number 2. Number 2, we're going to send this one to Nellie. Nellie, do I have a common denominator on number 2?
No.
That's both 6x to the 5th. So can we combine those?
No.
Let's do it. So I'm going to take this numerator. It was 5x minus 6y. Now, where we have to be careful here, guys, is that we are subtracting the 3x plus 4y. Who can tell me why I'm going to put this in parentheses when I'm subtracting the 3x plus 4y? What do I need to remember to do with that subtracting? What do we call that? Alright, well, what I was trying to get you to see is we have to distribute the negative. Sometimes what people will do is when they write it out, they'll put minus 3x plus 4y. But really the negative is going to make them both subtract. You get what I'm saying there? So let's actually distribute that negative. So I get 5x minus 6y minus 3x minus 4y. That's all over 6x to the 5th. So make sure if you're subtracting that you distribute the negative. Alright, so Braylon, what are our like terms? What can I combine in Awesome, what else? Yeah, because they're both x's. So great. 5x minus 3x is 2x. Negative 6y minus 4y, that is negative 10y. And then in the denominator, we have 6x to the 5th. All right. Do you have any questions up to that point? We had a common denominator, so we just subtracted the numerators, we distributed the negative combined like terms. Now we're actually not quite done yet. We can simplify this. Does anyone see a common factor with all of those terms? It's a 2, right? They're all even. So I can factor out a 2. Let me show you how to do that. In the numerator, I'm going to factor out a 2. That's going to leave behind x minus 5y. Because 2 divided by 2 is 1. Negative 10 divided by 2 is negative 5. What is 6 divided by 2? So what I'm going to do is write it like this. Because 2 divided by 2 is 1. And then there's my answer. That x minus 5y over 3x to the 5th. So always check if you can simplify, but remember it has to be factored out from all of the terms, not just one. Because I still have this force field here, but I factored it outside of it. Okay, cool. Do you have any questions on this? Those were the easy ones because they had a common denominator, okay? Now, let's look at 3 and 4. Do they have a common denominator? No. And this is when I get to tell you a story about my childhood. That story's great. So, when I was growing up, probably my favorite day of the year was Christmas morning. Maybe some of you can relate to it. But me and my family, we would all sleep in the same room, we'd stay up late, and then we'd wake up early, and we'd go out and open presents together. And it was always a fun moment, but I remember one Christmas, it wasn't so fun, because my sister got something awesome. She got hamsters. Does anyone here have hamsters? They're fun to play with, right? Well, my sister got hamsters, and I didn't. Well, my sister had asked for them, so it made sense. And I got what I asked for, but I didn't realize I wanted hamsters until my sister got one. So guess what I did? I was like 7, so I cried. My parents were like, "Why are you crying?" I'm like, "I want hamsters too." And then, anyway, poor kid. Anyway, have you ever been in that situation where a sibling gets something and you feel like you should get that too because your sibling did? Anybody? Like maybe your parents buy your sibling a car. And you're like, hey, if they get a car, then I get a car. Or maybe it's that your sibling has a later curfew than yours. You're like, whoa. If they get to stay out till 11, I should get to stay out till 11, right? We like to be treated the same. Well, guess what? These denominators are the same way. We need to treat them the same way. They get really jealous really easy, okay? Now, that was a weird story, but let's tie it into what I'm trying to get to here, okay? When I look at these denominators, are they the same? No. Do they have anything in common? Kind of, but you can't see it until we factor. So here's what we're going to do first. We're going to start by factoring the denominators. Oh, what am I trying to spell it? That's denominators. There we go. All right. When I look at 2x plus 2, what's the greatest common factor? What does 2x and 2 all have? Has a 2, is that what I heard? So if I factor out that 2, what's left behind? An x plus 1. Okay, now the reason why I did that is because do they have anything in common, those denominators? Yeah, they both have a 2. But one of them has an x plus 1. So this, I call it a sibling, like this fraction here. What is it jealous of? It looks over at this denominator, and what's it jealous of? What is it? It's jealous of the x plus 1. It's like, hey, Why does he get an x plus 1 and I don't? So what do we need to give it? An x plus 1. But if we're going to multiply the denominator by an x plus 1, what do we still got to do? Multiply the numerator, right? So let's I'm actually going to change the way I did that. So it's 3 times x plus 1 over 2 times x plus 1. The order doesn't really matter here. Plus 2x over 2 times x plus 1. Okay, are you guys okay with that so far? All I did was I said, hey, look, they both have a 2, but this one has an x plus 1. If we want to add it, then this one also needs an x plus 1. Now do we have a common denominator? Yep. So what does that mean we can do? We can add the numerators together. Well, to kind of speed this up, I want to do 2 steps in one. I'm going to distribute that 3, and then I'm going to add these so it's one fraction. So I'm going to have 3x plus 3, and then a 2x. And that's all over 2 times x plus 1. Jade, what can I combine? What are my like terms there in the numerator?
You can combine 3x.
And what would that become?
5x.
So this is 5x plus 3. And then in the denominator we have a 2 times x plus 1. And I would check to see is there anything I can factor out, but there isn't. That's all I can do. Alright. Do you have any questions in that process? Let's kind of look at it again. So I factored the denominators in order to make sure I could see what they had in common and what I still needed to give. Once I got a common denominator, we added the numerators, combined like terms, and we're done. Okay, let's do another one. 4 is going to be very similar, okay? So I'm going to ask for your help in doing this one. Step number 1, let's factor the denominators, all right? So let's send this one to Skylar. Skylar, looking at 3p plus 9, what is a GCF there? If I were to factor out that 3, what would that leave me with? So let me catch up 1 second. So if I factor out a 3, what's 3 divided by 3? Or 3p divided by 3? It's just 1, right? So that's just p. And what's 9 divided by 3? There you go. Okay, so we just factored out a 3. All right? So Skylar, what do those have in common? Those denominators. So they do have something in common, right? But this other one, what is it missing? It's kind of jealous. Because it only has a 3, where this one has a 3 and p plus 3. So what should we do, guys? Alright, let's give this other one a p plus 3, but if we put it in the denominator, we also need to put it in the numerator. So let's write this out. So we've got 5p times p plus 3. And then we've got a 3 with the p plus 3. And we're subtracting that with 3 over 3 times p plus 3. Louise, do we have common denominator? Awesome. So if we do, what can we do from now? From here? Yeah, that's subtract them. So I'm going to distribute this negative, or sorry, distribute that 5p. So I get 5p squared plus 15p minus 3. And then in the bottom we have a 3 and a p plus 3. Are there any like terms here? Can I combine any of those? Nope. Is there a greatest common factor? So the 3 goes into the 15, but not the 5. So I'm done. Like I guess it would be good for me to check to see, can I factor this? So I'm going to just write that out real quick right here, and let's check it. If I do 5p squared plus 15p minus 3. 5 times negative 3 is negative 15, and I want to see what multiplies to negative 3 and negative 15 and adds to 15. Is there anything that multiplies to negative 15 and adds to 15? Nope, so it doesn't factor. So guess what? You're done. Woohoo! Are you kind of getting a hang of the steps here? It's just like what we did with numbers before. If you have a common denominator, great, add the numerators, keep the denominator the same. If you don't have a common denominator, well then make them common, and then add or subtract them again. We're going to do 2 more examples and then we're done. Can you hang in there for 2 more? The more you participate, the faster it will go. So, let's, wait. I lied, we have 4 more. But we'll go fast, okay? We're halfway done though, okay? Okay, let's look at number 5. So, what's tricky on this one is I'm going to look at my denominators. Is there a greatest common factor? Is there anything I can do there? Anything I can pull out? No. So what do I do if I have a 3p plus 1 and a p plus 6? I want to make a common denominator. In this case, what you're going to do is just give this entire denominator over here, top and bottom, and this entire denominator over here, top and bottom. So let me write out what I'm saying. So the 3p plus 1, it needs the entire p plus 6. But if I do it in the bottom, I also have to do that in the top. Then the p plus 6, it's going to need the entire 3p plus 1. So I'm going to rewrite this out. Okay, so I've got 3 times p plus 6 over p plus 6, 3p plus 1. And then here we're going to have a minus 5p to the 3p plus 1 over p plus 6, 3p plus 1. All right, a lot of writing I know, but Antonio, do I have a common denominator now? Awesome, they're both p plus 6, 3p plus 1. So what do I do next? Yeah, you just combine them, right? You combine the numerators. Now I'm going to do 2 steps at once. I'm going to distribute the 3, and then I'm going to distribute the negative 5p. Make sure you remember that it's negative, okay? So 3 times p is 3p. 3 times 6 is 18. Negative 5p times 3p, that's negative 15p squared. And negative 5p times 1 is negative 5p. Like that, all right. Cool, so now we have distributed, we have 1 fraction. So Braylon, what are my like terms? What are there's only 2 of them, but what can I combine in the numerator? Awesome, so let's do that. I'm going to write this in standard form, so let's start with the negative 15p squared. And then we're going to do 3p minus 5p. Guys, what is that going to be? Negative 2p. And then we just have an 18 hanging out. Now, I'm checking this top for a common factor. There isn't one. Technically, we should check to make sure if that factors, but this gets ugly real fast because we would times negative 15 times 18. That's a really big number and say what multiplies to that, and that's negative 2. I'm pretty sure that doesn't factor, so we just leave it there. Okay?